Today, Peter Burns will be discussing the many forms of misconduct that are cropping up in scholarly publishing, highlighting solutions that any journal can put into place before ethical issues arise, and resources that could be helpful during or after a worst-case event. Peter Burns has worked in the publishing industry for more than 20 years. He spent several years as a copy editor at such publications as Popular Mechanics and the National Law Journal. In 2003, he joined Allen Press, where he worked as a managing editor for several years, and is now a publisher, managing 5 peer-reviewed journals. I'm going to go ahead and turn the presentation over to Peter to get us started.
All right, thank you, Joanna, and thank you, everyone, for joining us today for this webinar. I'm going to take kind of a high-level view of the state of misconduct in scholarly publishing. There's a lot of stuff to talk about here. There's been so much just in the past year or two that has even been covered in the popular press. I will refer to several articles from the mainstream press in this webinar. And I'm also going to provide some examples of misconduct and talk about specifically what types are among the most common, and provide some resources so that you can deal with misconduct before and after it happens. And I hope that you don't have to deal with misconduct with any of your journals, but it does happen. And what I want you to take away from this webinar today is that there are things that you can do, both to, if not completely prevent it, at least discourage it. And if it does happen to your journal, there are things you can do to properly deal with the misconduct and move forward. I'll provide numerous resources. We have several slides with links that could be very helpful, and we will allow time at the end for questions. So please keep that in mind and chat those questions in as we go. Types of publication, research misconduct. These are in no particular order, but they are among the most common. The first one here, redundant publication. Now I want to stress that sometimes it is perfectly acceptable to publish the same thing more than once, but the key here is to cite the original source of the publication. If you have a journal that has published a lot of material over the years on a particular topic, and you want to create a supplement or maybe a compilation of those articles, that's perfectly acceptable. But again, refer back to the original publication, say this article was originally published, and provide the citation. To do otherwise can be a type of misconduct. Plagiarism, I think most people understand, but keep in mind that can also include plagiarizing yourself, or as it has been euphemistically referred to as text recycling. I like that term. You can see in the cartoon here that this student has forgotten to do a science fair project, but thinks, maybe I could just reuse last year's. Well, that's probably not ethical, so want to avoid that. Then there's the term fabricated/falsified data, and to understand that distinction, it's generally accepted that fabricated data means that you've made the data up completely. In other words, the experiment was never conducted. You really have just pulled information out of nowhere. Falsified data is a little different in that there is an existing data set, but the scientist has manipulated the data in order to show the desired results. Now, this is approaching somewhat of a gray area, and I'm going to discuss that a little bit further in the webinar. But what matters here is whether or not there was an intent to deceive. And that is where being able to access the scientist's data can be very important when it comes to an investigation on an allegation of misconduct. So keep that in mind as well. Authorship also provides opportunities for misconduct. Anytime an author submits a paper and then wants to make a change to the author names, that should raise a bit of a red flag. And one best practice to consider here is that if any changes are made, all of the authors have to sign off on the change, including any author who is added or removed from a paper. Other types of misconduct can include conflict of interest. This can include at least a couple of major types of conflict. A commercial interest, for example, if an author holds stock in a company that's mentioned in an article. You could also have personal relationships that could create a type of conflict. And this is particularly applicable to reviewers who are being asked to review a paper that was written by a friend or colleague, maybe a former student. And it is worth encouraging reviewers in situations like that to recuse themselves from the review, or at least let the editor know, just to clarify, I know this person personally. It may be that the editor is okay with that, especially if it's very hard to find reviewers or if your expertise is considered essential to the review, but there's some potential there for a conflict. Peer review misconduct can also include something that we've seen a rash of in the past year or two, which is fake accounts being created in peer review systems. And the way this has worked is an author will go into the peer review system, create some fake accounts, typically using email systems like Yahoo or Gmail, and then they will create fake identities to go along with those people. When they submit their manuscript to a journal, then they recommend those non-existent people as reviewers for their manuscripts and ultimately end up reviewing their own papers. Now, some people would look at this and say, well, you shouldn't be accepting the reviewers that have been suggested by an author in the first place. And there's an interesting debate to be had about that. Sometimes it is really helpful for an editor, especially in a field where it's hard to find expertise, for the author to recommend some reviewers. A best practice here to help avoid this type of scam, though, would be to only use one suggested reviewer and make sure that you get one or maybe two more reviews from someone who was not suggested by the author. It is something that has happened and has led to multiple retractions of papers, so it's something to keep an eye on. If nothing else, if you have any questions regarding a reviewer's identity, look for that person on the internet or try to find out more about them. Make sure that it is a real person and not a fake account. It's also possible to have conflict of interest there, as I just discussed, and to have a reviewer who steals an author's idea. We hope that doesn't happen, and it's very hard to catch when it does, but it has been known to happen. And I'm sure you've noticed the image of the dog here on this slide. Yes, figure manipulation happens. It is certainly a form of misconduct. At least in this case, where we can see what's going on with this poor dog, it's pretty obvious that someone has been playing in Photoshop. Most of the time in a scholarly paper, it's a little more subtle than that. However, there are tools that can be used to help identify when someone has been playing around with an image, and I'll refer to that later in the resources. Other types of misconduct that may not directly apply to a publication but can certainly affect the scholarly process, destroying data. And this is important because whenever it is time to investigate an author for an allegation of misconduct, as I mentioned before, intent to deceive is an important part of the formula, and having access to all of the original data is sometimes the only way that that intent can be proven. So if someone is destroying their data and not leaving a trail for others to follow, that's definitely a type of misconduct. It's also possible to encounter misconduct in grant applications. And this includes not just use of data or fabricating results, but even misrepresenting oneself. For example, if you apply for a grant and you say you have 3 PhDs, you really should have 3 PhDs. And yes, people's grants have been rejected because of things like this. There are also, of course, human and animal welfare issues. And anytime someone neglects to adhere to the standards of research in those areas, that's a problem. And of course, anytime you're talking about publishing, there's a potential for misconduct involving copyright violation. And that can come in a couple of different forms. Somebody can appropriate material that has been published somewhere else and reuse it in their publication, or sometimes just disseminating content with disregard for copyright can also be misconduct. So to try to get a handle on which types of misconduct really happen most frequently, this was taken from an article in the New York Times which used data that came from Retraction Watch. And I'm going to refer to Retraction Watch more than once in this webinar. If you haven't encountered it, I would recommend that you check it out. Retractionwatch.com posts articles every day, sometimes more than once a day, about retractions and really tries to dig in and get the story behind those retractions, and also tries to compile the data into a big picture. So from the New York Times analyzing Retraction Watch data, the 4 most common types of misconduct in order are image manipulation, plagiarism, duplicate publication, and fake or falsified data. Regarding false data, this is an example of that. This is a fairly high-profile case from earlier this year when a study was retracted because the raw data that supported the study could not be produced. This was a study in which the report itself claimed that if someone were conducting a poll or a survey regarding gay marriage, and they revealed in talking with the person taking the survey that the person conducting the poll was gay, would that knowledge affect the outcome? And there was data supposedly that supported that yes, it would. And if true, this would have enormous implications for conducting surveys and conducting political polls or public opinion polls. So it made big news when it was published, but it quickly started to unravel, and the lack of data caused the study to be retracted. Regarding self-peer review, now this is a screenshot from Retraction Watch illustrating that the total number of articles that have been retracted because of fake peer reviews is up to 250. Now I want to stress this says has a reference to Sage journals. Not all 250 of those articles came from Sage journals. So I want to make it clear that that one publisher is not responsible. This is something that has affected multiple publishers, and a lot of people are scrutinizing their peer review process to ensure this doesn't happen. It's also important to understand that in different countries there can be a different standard of misconduct. This article came from the New York Times and describes a difference in philosophy between East and West. For example, in China, sometimes there is a lot of pressure on scientists to push the boundaries and, for example, to conduct experiments on human embryos. That's something that most scientists, at least in the West, would frown upon, but in some places it may be considered acceptable. This is an article from the Journal of the Medical Library Association, which also discusses the international implications for the ethics in scholarly publishing. And in this study, it showed that the U.S. has the most retractions numerically, and China has the most specifically for plagiarism and duplicate publication. But that is not so surprising because the U.S. and China produce an enormous volume of research. If you look simply at the rates of plagiarism, they're actually highest in Italy and Finland. So interesting study that shows that in different countries, different things lead to retractions. which gets us to the question, how bad is the problem of misconduct in scholarly publishing? Well, it can be difficult to get a handle on, but we'll try. This is also from Retraction Watch data, and it shows that since 2001, the number of retracted articles has increased tenfold. Now, Retraction Watch is tracking about 10,000 different journals in science and medicine. And the number of retractions annually is running about 500 to 600 currently. And the causes of retractions generally fall into two camps. Either they are caused by misconduct or they're caused by honest errors. And so it's important to keep in mind that just because an article has been retracted, that doesn't necessarily mean someone has done something inappropriate. Sometimes they're retracted simply because there was a miscalculation in the data or something happened that the authors didn't catch until after publication. But fully 2/3 of articles are retracted because of misconduct. And if you're not familiar with the website PubPeer, this is a place where people go to comment on articles. Now, they're not hosting content. What they're doing is providing a venue for discussion. And so a lot of people have gone onto PubPeer and discussed articles that they've seen published in journals. And during the course of these commenting, people have actually gone in and made comments regarding misconduct and said things like, hey, I think I've seen that figure in another paper, or I don't agree with the conclusions that this author has come to. Can they provide the data to support this? And because of these comments, a number of papers have been retracted. And so PubPeer published a post about a year ago called A Crisis of Trust, in which they delved into this matter a little bit and said, we've come to believe that these comments are symptomatic of a deep malaise. Modern science operates in an environment where questionable practices and misconduct can be winning strategies. So clearly there is some degree of a problem with misconduct in science, but to what extent? Well, one attempt to answer that question was an article that ran in the journal PLOS One that said about 2% of scientists have admitted that they have fabricated, falsified, or modified data or the results at least once. However, this is considered a conservative estimate of misconduct in scholarly publishing because the study did not include some of the more common forms of misconduct like plagiarism. So we would have to think that perhaps more than 2% of scientists are engaged in some form of misconduct. But one interesting question, I think, is how does that compare with other professions? Again, it's hard to get really good comprehensive data. But I did find a study that showed that overall estimated rates of disciplinary action against licensed physicians ranged as high as 2.8%. Now, this was limited to physicians just in Canada, so it's not clear that that's representative of the entire medical profession. And also keep in mind that compared with the other study about scientists, we're comparing apples and oranges because that was the first study was involving an admission of wrongdoing, whereas this one has to do with disciplinary action. So to look at one more profession for comparison, attorneys. The American Bar Association says that more than 1,000 lawyers were disbarred in the U.S. in 2011, but that's a fraction of the roughly 1.27 million lawyers practicing nationwide. And again, this is yet a different standard of comparison because being disbarred is different from being investigated or from admitting wrongdoing. I would be really interested to know if there are other studies out there that provide a more comprehensive view of misconduct in any professions, but it was very hard to find very much data on this. So I think one conclusion is that more data is necessary and more studies need to be done. So to look at misconduct and the problems that it causes, I spoke to a couple of people, including Ivan Oransky of Retraction Watch and Dr. Kristen Grace of the Office of Research Integrity, and also just from reading articles and talking with other people, it's clear that there are several problems that can be traced back to misconduct. One, for a real big picture view, is simply trust in science. I mentioned that the mainstream press has been covering misconduct in science a lot more lately, and I think that is causing people to wonder, well, what can I believe and who can I trust? There are implications for public health and other real-world implications. Quite notable that Andrew Wakefield published a paper years ago that we're still dealing with regarding a potential link between vaccines and autism. A tremendous amount of evidence has refuted that connection, but it's something that has taken hold in people's consciousness. We're still dealing with that. Similarly, a scientist named Derrick Coleman fabricated data on menopause and female metabolism years ago. He was sentenced to prison and paid about $200,000 in restitution. But for some, damage had already been done because the results of his studies, which had been made up, had already been disseminated. When I talked to Dr. Oransky of Retraction Watch, he said to him one of the most upsetting things about misconduct was simply the waste of resources. You know, to make it as a scientist, you have to be smart, you have to be talented, and the fact that people who otherwise could be performing very helpful and productive research are involved in misconduct is really a waste, not to mention the financial waste of grant funding that has been squandered. And if you look at Retraction Watch, you'll see that people's careers certainly can go down in flames because of this. But also consider not only the scientists who are guilty of the misconduct, but the collateral damage. If you run a lab and you find out that one person in your lab has been guilty of misconduct, that can have an effect on everyone in the lab. So a lot of innocent people have been affected by research misconduct, and that also seems to be a waste. And some scientists have actually faced fines and jail time. I mentioned Eric Coleman a minute ago. There was also recently an Iowa State researcher who faked data in an AIDS study and was sentenced to more than 4 years in prison and has to pay back millions to the National Institutes of Health. However, it's notable that this is really quite unusual. And one thing that will be interesting to see is if those types of punishments increase over time. And of course, there are legal issues, as I just mentioned. And also, to put retractions of articles into some kind of bigger perspective, it's hard to say with absolute certainty whether an increase in the number of retractions means that misconduct itself is growing. It's possible that we're just getting better at detecting it. But I'd like to step back for a minute and look at how science is conducted and consider that just because an article is retracted, just because someone comes along and says, wait, I'm not sure about the conclusions that the author has presented based on the data, that doesn't necessarily mean that there's misconduct involved. What it means is science can be very, very difficult. So this comes from an article that was published recently on the website 538. And what this is an article called Science Isn't Broken. This interactive graphic is really fun to play around with, and it also illustrates an important point, which is that this graphic was created from an actual data set. This is real data taken from real studies, but by manipulating the variables, it is possible to show, on the one hand, that Republicans are better for the American economy, or by choosing different variables, that Democrats are better for the American economy. Either way, it is possible, manipulating all these variables, to come up with a result so significant that it could be considered publishable in a journal based on how the data shows up in the p-values. So I would encourage you to check this article out and play around with this, and keep in mind that if you can use the same type of data and by playing around with the variables come up with completely opposite conclusions, that the same thing can happen in the real world, and sometimes that's just how science works. Now, some people have complained that maybe the p-value is not the standard to be using for publication, and I think that's an interesting point, a whole different debate, and that debate is ongoing. But I think what this illustrates here is that maybe there's a gray area regarding the nature of misconduct. Certainly, as long as there's not an intent to deceive, a good case could be made that no misconduct was going on, but it certainly illustrates that science is difficult. And this is an example that shows that by changing one of the variables, we ended up with a publishable result. So again, play around with this graphic and see if you can find the publishable results to show two completely opposite things. And this comes from the website XKCD, which has some great stuff and some good science-oriented cartoons. And this shows the range of potential p-values and what to do about different ones. So again, taken from the article, science isn't broken, nor is it untrustworthy. It's just more difficult than most of us realize. So we've seen some of the types of misconduct, and we've looked at some of the gray areas here, but let's talk about solutions and what can be done. So a study from Donald Kornfeld of Columbia University evaluated the state of misconduct in scholarly publishing, and Dr. Kornfeld makes a couple main recommendations. One is improved mentoring would help, and he's talking about mainly at the institutional level. In this case, he mentions that one of the main challenges for young scientists is that they're very bright, very ambitious, and they're used to being successful. However, it may take a mentor to get across the point that you're not going to be successful all the time in science. And the pressure that is on scientists to produce useful results and to be published in high-profile journals, many believe that's leading to an increase in misconduct. To alleviate some of that pressure, it's a good idea to work with young scientists and make sure they understand that sometimes things just don't work out in the lab, and that's okay. We just keep trying. If you're going to implement a mentoring program, it's important to have a reasonable mentor-to-trainee ratio, and also to involve the mentor in sharing responsibility for the trainee's work, at least for a limited time. And also, institutions that implement these programs should adopt guidelines so that everyone's clear on the expectations. Dr. Kornfeld also recommends that we all acknowledge and understand the role of whistleblowers. I mentioned PubPeer. It's possible to sign on to the PubPeer website and make comments anonymously. The folks at Retraction Watch also say that they get a lot of anonymous tips from people about articles that are being retracted or maybe that should be retracted. And so in a way, these whistleblowers are helping keep science honest and keep the results true. So what Dr. Cornfield says here is we need to make sure that people are not afraid of retribution when it's time to come forward and say, look, I think some misconduct is going on here. The article in PubPeer also offered several solutions, one of which was to create a centralized system for documenting the results of plagiarism. Imagine if an article submitted to Journal A and they detect plagiarism and reject the article, there's nothing to stop the articles from submitting to Journal B and potentially having it accepted. So there's a case to be made for sharing information, although how that works in practice, I'm not sure how that would happen, but it's an interesting point. And also, not only PubPeer, but others have made the point that scientists who are engaging in misconduct and it comes to light, they need to be punished, and severely, because it is a waste of resources. It does damage trust in science, and it needs to send a message to others that it won't be tolerated. Now, they make an interesting point here also that researchers should be able to back up their claims with raw data and with facts. So they make a case that shifting the burden of proof to the researchers themselves is appropriate. And they and others also say that improving access to data is important. And among other recommendations, PubPeer says a thorough description of the methods in published articles is very important. Now, I know what you're thinking, and I thought the same thing. A lot of articles do publish a very detailed description of their methods, but I make the case here that sometimes those descriptions are not really detailed enough to be able to replicate a study. And so journals need to make sure that they are publishing all of the details, because replicability is one of the keys to ensuring the results are valid. And they also recommend a centralized and public discussion about published research, which of course is what PubPeer provides, and there are others that provide similar. So I would also recommend that publishers and editors look up the Committee on Publication Ethics. A number of resources that I'll be providing at the end of the webinar also cite COPE and refer in particular to their flowcharts. Now, COPE has put a lot of effort into helping editors know how to deal with an ethical situation. And so, depending on the situation that you're facing, these flowcharts can help decide whom to contact and what to look for in a response, and decide how exactly to deal with misconduct, whether it's suspecting of fabricated data or plagiarism. There are several of these flowcharts available on the COPE website, and they could be really helpful to an editor who maybe hasn't encountered any type of misconduct before. So among other solutions and things that, in my opinion, editors and publishers should consider, establish a policy for transparency and for handling allegations of misconduct. Let authors in particular know that misconduct will not be tolerated, and inform them about what will happen if any allegations come forward. I should also mention here the Office of Research Integrity. This is a part of the Department of Health and Human Services, and so their jurisdiction is a bit limited, but it is a big jurisdiction. This includes all funding from National Institutes of Health, for example. And when I spoke to Dr. Kristen Grace of ORI, she encouraged journal editors to contact her office directly. Sometimes they don't think about doing that. It's also acceptable for editors, and sometimes advisable, to contact the funding agencies directly, and they in turn may contact ORI. But keep in mind that funding agencies typically are not awarding money to individuals, but to institutions. And so the institution also has very much an interest in ferreting out misconduct. So if you're going to contact someone at an institution, perhaps look for the research integrity officer or someone who plays that role and contact them and let them know. One advantage of doing that is that they are in a position to handle the investigation, and they're also in a position to monitor the research itself, especially the data. And one of the things that can hamper an investigation into misconduct is destruction or mishandling of data. I also mentioned figure manipulation earlier, and ORI provides tools for checking figures. So I provide a link to that at the bottom of this slide. Also consider using plagiarism detection software if you're not currently. Now a word about that, plagiarism detection software can be very effective, but it doesn't necessarily give you a thumbs up or thumbs down as to whether or not plagiarism has occurred. What it typically does is provide you a percentage of duplicated text compared with a search for articles in other journals and even on the web. So there is still some work on the part of the editorial office and maybe some judgment calls, but again, used in conjunction with an established policy and perhaps a resource like the COPE flowcharts, plagiarism detection software can be very helpful. And I am aware of journals that when they started using the software, they quickly uncovered that there was more plagiarism going on than they thought there was. So that can be worth looking into. I also think it is really important to document all communication and to collect copyright forms and just make sure that all the documentation is in order. If you're using an online peer review system, that can be really helpful because all communication about an article stays in the system. I think oversight is also important, and I've seen many different models for this, but especially for society-owned journals, I think it's important to consider who has oversight over a journal, and then if it's a single person, such as the editor, consider who has oversight over that person. Is there a board of directors or a specific committee that is there to make sure that the editor is performing the job appropriately? And keep in mind that there have been cases in the past where the editor has actually been engaged in misconduct. So it's a good idea to have some checks and balances and to have somebody there so that if somebody thinks the editor is doing something wrong, it's possible to go to somebody else and ask for help. And I hope it doesn't come to this, but if it does, it would be a good idea for society or any journal owner to have legal resources available to them. There have been cases of journals being sued, sometimes in disputes with authors or sometimes regarding copyright issues. Whatever it is, it's important to have those resources available. And I think it's also important to establish a policy for setting the record straight. If it's a matter of deciding when to publish a correction versus when to retract an article, for example. And if you do retract an article, what is the obligation in terms of the information provided, the amount of detail and the amount of history? Some good resources for this are an article from Retraction Watch that lays out what, in their opinion, the ideal retraction notice would look like. And PubMed also publishes information about errata and other things that are worth looking at, like duplicate publication. So very helpful resources there. More helpful resources, I've got several slides here that I think could be helpful. Of course, the COPE flowcharts that I mentioned earlier. Several industry groups have also created principles of transparency. And this is interesting because, among other things, this urges publishers and editors to take reasonable steps to avoid publishing any papers that involve misconduct. And it's also, the recommendations here are also designed to combat non-legitimate publishers, also known as predatory publishers, which is a whole other form of misconduct that I haven't even mentioned, but the recommendations there should help avoid any problems with that. And again, the Office of Research Integrity can be a great resource. Science has new transparency guidelines that you might look at, could be a model for your journal. NIH has research integrity and research misconduct policies and guidelines. And a very helpful resource from the Council of Science Editors, which provides not only very thorough recommendations for editors about handling misconduct, but even provides sample correspondence. Again, used maybe in conjunction with the COPE flowcharts, can be helpful for an editor who's never encountered misconduct before. Also recommendations from the International Committee of Medical Journal Editors, the World Association of Medical Editors, and this was an interesting one, the policy for journal editors that comes from the University of North Carolina at Charlotte. Among other things, it discourages questionable citation practices. I mentioned earlier that sometimes editors are engaged in misconduct, and this is considered a form of misconduct. If an editor tells an author, look, we'll accept your paper, but we want you to cite several other papers that have been published in this journal, that's a blatant attempt to try to increase the journal's impact factor and is considered a no-no. Also, Allen Press has done presented some presentations on scholarly misconduct. Back in 2012, our Emerging Trends in Scholarly Publishing seminar had a session doing battle with author misconduct, and those presentations are archived on our website. And Retraction Watch has published something on the debate regarding whether or not the pressure on scientists today can be blamed for misconduct. That's an interesting debate. It gets to the heart of why people would allow themselves to get dragged into misconduct and risk being caught. But when you understand how much pressure people are under to publish and to provide interesting findings, it sheds some light on this problem. And then in addition to the resources, I've provided some links here just to additional reading if you want more background on misconduct. The COPE Vice Chair, Charlotte Haig, talked with the Scholarly Kitchen. You can either listen to the podcast or download the PDF transcript. And I think it's worth mentioning here also that Biomed Central is in the process of launching a new journal called Research Integrity and Peer Review. Hasn't published anything yet. They're currently accepting submissions, but what they say on their website is they're particularly interested in submissions that identify problems involving misconduct and also offer solutions. So I think it'll be interesting to keep an eye on that journal and see what gets published there. And we're almost at the end. There is also a good paper from Academia EDU. You can either read this on screen or join, and you get to download the PDF. This paper is called The Prevalence of Research Misconduct. And then recently on mendelspod.com, Dr. Ivan Oransky of Retraction Watch discussed today's boom in retractions. And that's it. So we still have time for questions, and I hope you've been chatting those in to Joanna. And I'll turn it back over to her.
Great. Thanks, Peter. We do have a couple of questions that came in, so we'll go ahead and try and address those. So first, is there an estimate of how many cases of plagiarism are self-plagiarism versus plain old plagiarism, and are they handled similarly?
Oh, that's a really good question. I don't have any data. As you see in the webinar, it's hard to get really comprehensive data on any particular type of misconduct, and I haven't seen anything on the distinction between plagiarism and self-plagiarism. I do think it's possible that they could be handled a little bit differently because, and I've seen this argument raised a couple of times, sometimes if, especially if the degree of duplication is fairly small, and if you're talking about a really technical subject, it's possible that there are really only so many ways to say the same thing. So if someone has lifted, say, a couple of sentences from something they published earlier, and it really is hard to reword those phrases without changing their meaning, then I could see an editor letting something like that slide, even if it gets flagged in plagiarism software. I do think it would be a recommended best practice for that author in this situation to cite the original paper, especially if it's your own paper. Why not increase your own citations, especially if it's a legitimate citation? But if it's coming from another source, I think it's always appropriate to cite those sources, even if it's your own paper. So yes, I do think there's room for some judgment there and maybe a little gray area. But no, I don't have any stats on the new numbers or rate of occurrence.
Great. So, Peter, do you have any recommendations for batch processing of images, checking for misconduct? One of our participants pointed out that the ORI tools are useful, but very time-intensive.
That's a really good question. I haven't encountered that, and I don't have experience personally with looking at images and trying to detect manipulation. So I can't really say how that works in practice, but I have heard some idea about what is considered misconduct there. For example, if you're going to do something to make a figure or an image more legible, or make it easier to see what it is you're trying to highlight in the image, it's considered acceptable to make a change to the entire image. For example, if you want to change the contrast, if you do that to the entire image, that can be considered acceptable. And I understand that if you want to go through a bunch of images and you want to check for something like that, that could be time-consuming. Unfortunately, I just don't know that there's a shortcut for that.
Great. So some societies avoid setting a policy for misconduct because they are reluctant to enforce such a policy. So what would you say, Peter, are the implications for a society if they choose to just ignore the problem?
Well, I think it's a great question. I really appreciate somebody asking that because I think it gets to one of the things that it makes it hard to deal with, which is that it's a messy problem and it can be time-consuming. But I would encourage you to look at some of the resources I've provided and consider the fact that very few people really expect an editor or even a society to conduct an entire investigation of misconduct. That is most commonly going to be handled by the author's institution, maybe the funding agency. So I think it's important for editors to understand what's really expected of them. And if you go through the COPE flowcharts and if you look at some other recommendations, I think you'll see that at some point most of these investigations are turned over to someone else. I think it's important, though, to let authors know that misconduct is not going to be tolerated. And if you do detect it, I don't think it solves anything to sweep it under the rug and pretend you didn't see it. On the other hand, yes, I sympathize with the amount of effort that goes into this. But again, having a clear policy from the beginning and making it known, that in itself may help prevent some of the misconduct and help you have to avoid dealing with it.
Great, thank you, Peter. It looks like that's all the questions that we have. If you do think of questions, later on today or later in the week, feel free to send those in to us via Facebook or even Twitter, and we'll try and get answers out for those questions as well. So I do want to thank Peter and everyone who attended the webinar. I hope you enjoyed today's presentation and learned a few things.